is to create a single dimensional array and that too of any size and then enter the numbers randomly, and your program should print only the prime numbers, number of prime numbers, how many prime numbers have been entered in the dimension, or the number of prime numbers entered in the list. So as you know, the comma lines has to be there, and the variables being declared, they need to be used in the execution of the program. And as the question says, the array has to be any size. So first we are going to enter the size of the array. Enter the size of the array n. Let us say n, the size we have entered is 7, and once the variable n has been given as 7 in the rough column, so declaring of array of the dimension, that you declare in this way, that you know well, int a square bracket is equal to new int n. So n we are given 7, so the dimension will be created for 7 or 7 cells. So now it is time to enter the numbers, and to enter in the numbers we need a for loop. I am using a for loop. So first time the I will be 0, because as per the rule, dimensions, the first box is the index or position is 0. So 0 less than n. N is 7, 0 less than 7, true. As it is true, it logs enter any element. So now let us say, for example, a of I. So a of I is 0. So a का 0th box. So the 0th box of a, dimension a, we have to enter the number. Now let us say we have entered the number 11. So once 11 is here, we have to check whether it is a prime number or not. So this is the program for the prime number. And you know well the program of the prime number, you might have seen, you might have done earlier. So once it checks for the number of zeros, very clearly I have given here in the documentation, counting the number of zeros. As there are 2 zeros when it is divided for the modulus, so if it comes to 2 zeros, that means it is a prime number. 2 zeros in the sense after getting the modulus or the variable, I mean the remainder. So the remainder, if the remainder is equal to 2, the count is the number of remainders, number of zeros. If it is equal to 2, then it is, we are going to count the number of prime numbers. So 11 is a prime number, so num prime plus plus. So it has been declared as 0, now it is 1, and count has to be given as 0 again. Otherwise, next numbers, even if it is a prime number, it cannot be a prime number because number of zeros will grow little more than 2. So it has to be initializing back to 0 again. Count has to be initialized back to 0 again. So the loop will go back, j plus plus, j will become 1, 1 less than, it will go back to this update, the I plus plus, I will become 1, and 1 is less than n, that is 7, true. So it will ask you to enter another number. So let us say this time is 12. So in the dimension you have entered 12, and we are going to check whether 12 is a prime number or not, counting number of zeros, and of course number of zeros will be more than 2, so it is not a prime number. So it will not go to num prime plus plus, and also it is not going to count this also. And again similarly we are going to enter till 17, 11, 12, 13, 14, 15, 16, 17, and at the last, by the time it is calculated, 11, 13 and 17 are the prime numbers. So it should give us system.print a number of prime numbers in the array are num prime, as 11, 13 and 17 are prime numbers. It should give us the number 3. So we'll see the output. We'll give a click on compile. So once you give a click on compile, it is compiled now, and I'll show you the output. It is asking for the size of the array. Now let's say the size of the array is 7 as I said. Enter any element, 11, 12, 13, 14, 15, 16, 17. See, 7 arrays has been declared, so 7 numbers have been entered, 11 to 17, and number of prime numbers in the array are 3. Very clearly it is saying 3, as 11, 13 and 17 are prime numbers. So there are 3 prime numbers in the dimension. So this is how you have to check in the rough column also.